Today on How It's Made. Recycled skateboards. Braided pastry. Construction trailers. And metalworking vices. "60 years ago, surfers in California were looking to ride the streets like they surfed the waves. They came up with an idea to strap roller skate wheels on their surfboards, and the skateboard was born. Since then, skateboarding has evolved into a sport, a passion, and a lifestyle for people all over the world. In a backyard pool, a skater gauges the feel and response of these recycled skateboards. Recycled skateboards give new life to unrideable old boards. The boards on this rack would normally end up in a landfill. First, the designer heats up the old grip tape and peels it off. This reveals the board's original graphics. He grinds off the graphics, leaving bare wood. He applies epoxy on top of a colored veneer coating and stacks the boards on the table of a bottle jack press. He glues another board and places it on top of the first one. He repeats the stacking process with different colored boards. The stacking continues until the designer has about 20 boards on the table. He puts the bottle jacks in place and cranks them up. Each jack applies 10 tons of compression, pressing the boards together while the epoxy cures and the excess glue drips out. The designer makes a crosscut in the stack with a bandsaw. Each new board he makes comes with a unique color design. A worker traces a cutting mark on the board and makes a rough cut along it with a jigsaw. He sands down the rough profile of the board using a table-mounted belt sander. Before the board goes to silk screening, he uses a custom template to drill holes for the assembly bolts. A designer pours water-based ink on top of a screen printing mesh. He takes a squeegee and pulls the ink through the membrane to print the company logo onto the board. He removes the silk screening frame, and the board continues on to the epoxy phase. A worker pours epoxy resin on top of a fiberglass cloth. He spreads out the epoxy with a squeegee in a slow, constant motion. This keeps air bubbles, runs, or drips from ruining the finish of the board. The cloth absorbs the resin. The worker cuts off the excess cloth with a razor blade and applies a finish coat of epoxy, completing the board's covering. A worker uses a router to smooth out the curve of a different board. He finishes the board profile with fine sanding paper. A worker sprinkles recycled crushed glass on the epoxy-covered board. This will provide grip for the board instead of grip tape. Before the resin hardens and cures, he presses the glass into the epoxy with a wheel. He sands the bottom of the board with a sanding block. He goes through 7 different grits of sandpaper. Then the board is washed and polished before starting the final assembly process. A worker assembles the wheels on a truck and bolts them on with hex nuts. He tightens the wheels with a wrench until he's reached the desired torque ratio and gives them a test spin. He inserts bolts through the board and places a urethane riser pad underneath the skate deck. Then he starts assembling the truck. He uses a screw gun to secure the wheel trucks in place. Each skateboard is equipped with polyurethane wheels mounted on metal trucks. These allow the rider to steer and control the board. Recycled skateboards are made from a wide variety of shapes, deck sizes, wheels, and trucks, suiting each rider's unique tastes and performance needs. Many years ago, Danish bakers got creative with pastry dough. They began braiding it, putting a whole new twist on desserts. Braided pastry looks more elaborate than ordinary pastry. The flakiness of the dough and the scrumptious fillings make braided pastry taste as good as it looks. Factory-made braided pastry can be kept frozen until you're ready to eat it. After just a few minutes in the oven, you will have a fresh baked dessert. The pastry looks as though it takes many hours to prepare. But of course, it is no trouble at all. To produce braided pastry, this factory uses a number of ingredients, including yeast, granulated sugar, pastry flour, dried eggs and water. The ingredients go into a large refrigerated mixer. The cooling keeps the yeast dormant as beaters work the ingredients into dough. After the dough leaves the mixer, it tumbles into a hopper. A cutter wheel chops the dough into several pieces. The pieces of dough travel between conveyors that squeeze them into ribbons of dough that will be fed to an extruder. The extruder shapes the elongated dough pieces into one continuous sheet. At the exit of the extruder, an employee dusts the conveyor with flour. This prevents the dough from sticking to it. A pump at the extruder exit spreads big blocks of soft butter across the newly formed sheet of dough. Down the conveyor, plow light flaps fold the buttered dough over, creating a double layer. This folding process, called lamination, will build up multiple layers of buttered dough, resulting in a very flaky pastry. Next, the dough travels into a drum with spinning rolling pins. These rolling pins flatten the folded dough significantly, compressing the layers into one thin sheet. Now, a conveyor takes the compressed sheet through a device that will fold the dough again. Next, rolling pins squeeze the stack of dough into a single piece once again. Revolving cutters slice the laminated dough as it moves forward. The cuts create angled strips for braiding. At the next station, a sweet cherry filling with a jam-like consistency is waiting. Nozzles deposit precise amounts of cherry filling between the angled cuts. Next, workers braid the dough over the center filling, creating an attractive-looking pastry. Sensors determine where the blade will slice the braided pastries. The braided pastries are transferred to another conveyor with a scale. The scale confirms that there is a sufficient amount of filling in each pastry. The braided pastries now head into a freezer set at a temperature of 29 degrees below zero. Inside the freezer, the pastries revolve on carousels for 45 minutes. This gradual freezing process preserves the yeast. Next, the pastries wind their way toward the packaging station. Here, workers place a packet of icing under each braided pastry and send them to an automated packager. Machines wrap a plastic sleeve around the pastry. To minimize the amount of time the pastry is out of the freezer, things must move quickly. The pastries pass over a weigh station to confirm the correct amount has been packaged. When baked, the pastry rises significantly, allowing the braided profile to expand. The layers of dough separate and become flaky. The cherry filling seeps into the pastry. Endings don't get much sweeter than this. Pass by any construction site and you'll probably see a trailer. Construction trailers provide room for an on-site office or lunchroom for the construction workers. A trailer can also be used as a decontamination room for workers to remove their protective clothing and shower after handling hazardous materials. Construction trailers are typically 10 to 13 feet wide and up to 59 feet long. The inside of the trailer can be equipped for whatever function it will serve. The structure of the trailer is made of spruce, pine, or fir. Workers start with an underfloor made of wood particle board. Then they nail floor joists to the board and frame them. They insulate the floor with fiberglass wool and nail a plywood subfloor on top. Then they spread tile glue over the subfloor. The glue is freeze-proof and mold-resistant. They complete the floor by laying down commercial-grade vinyl tile or linoleum. To build the walls of the trailer, they nail pieces of wood called studs every 15 inches along the sole plate. The sole plate is the bottom section of the trailer's wall. Then they build rough openings for the windows and doors. Finally, they nail another horizontal piece along the top of the studs. This is called the double top plate. The structure of the wall is complete. Now they apply glue to the studs and nail on a sheet of plywood to the lower part of the wall structure. They repeat this process with the 3 other walls of the trailer. Then they raise each wall and nail its sole plate to the floor. The plywood exterior wall extends below the sole plate, covering the side of the floor frame. They glue the plywood to the floor frame and reinforce it with nails. Next, the roof of the trailer. It is constructed in layers. First, they lay down the fiberboard ceiling. Then install a plastic vapor barrier. Next, the roof joists. The joists have sloped edges to drain water off the roof and holes for electric cables. Once the joists are installed, workers frame the roof structure with end plates. Then they thread in electric cables for the lights, outlets, baseboard heaters, and other electrical components. Now they begin their work inside the trailer. First, fiberglass wool insulation is installed between the studs. A plastic vapor barrier is added. Then they install smooth wood panels. The wood panels are laminated with vinyl for a clean finish. At the same time, work continues on the outside of the construction trailer. Under the floor, workers install 1 to 3 axles. The amount depends on the trailer's length. Each axle can support around 2.5 tons. After workers install all of the exterior plywood, workers begin the finishing process. At the top and bottom of the trailer, they install starter moldings made of painted sheet steel. Then they begin installing panels of painted steel. Windows and doors are installed before adding the painted steel siding. This is so the ends of the steel siding will go beneath the door or window moldings, producing a neater finish. Trailers longer than 32 feet have both heating and air conditioning via a duct system. Workers mount the air ducts to the ceiling with brackets. They also install electrical outlets, light fixtures, interior trims, and electric baseboards for additional heating. Trailers shorter than 32 feet only have electric baseboard heaters and a window-mounted air conditioner. However, there is the option to upgrade to the full duct system. To finish the roof, they staple white fiberboard to the roof joists. Then a hitch system is installed. This enables a truck to haul the trailer to and from the construction site. A metalworking vise holds a piece of metal in place so that a computerized cutter can shape it into a part. You often see vices on how it's made. Now it's time to find out how they are made. Metalworking vices have parallel jaws that close tightly around a piece of metal. Their firm grip allows a part to be machined with pinpoint accuracy. To make a metalworking vise, they start with a steel rod. It spins in a lathe as tools carve threads into it. The result is a lead screw that will be used to open and close the jaws of the vise. Next, cutters transform a piece of aluminum into a thumb screw. The thumb screw is used for turning the lead screw. The outside of the screw is given a knurled texture for better gripping. The final tool shaves the rough-edged rim of the screw to make it smoother to the touch. This completes the thumb screw. Now, an automated saw cuts a steel bar into smaller pieces. Each piece will be used to make the base of a vise. Next, a cutter sculpts the outside of a base piece to the desired profile. Another tool carves a channel in the center of the base piece. The cutting machine also creates components for the vice's shuttle system. Then, a machine cuts the reverse side of the vice base flat and smooth. It also drills holes for mounting the vise to milling equipment. A constant flow of coolant is applied to protect the tool from wear. Next, a steel block is locked in a vise. Yes, they use vices to make new vices. The vise holds the piece of steel firmly in place as tools shape it into one of the new vice's jaws. After After a heat treatment, they spray small particles of sand onto the newly formed jaw. The sandblasting removes blemishes. A worker now submerges all parts of the vise in a hot chemical solution, leaving them there for 8 hours. This chemical solution gives the parts a black oxide finish and protects them from rust. Here is the vise before and after the oxide treatment. Next, a laser etches the brand name, part number, and basic dimensions onto the base of the vise. Then, a probe gauges the size of the mounting holes. It also determines if they've been drilled in the correct location. Now it's time to assemble all the parts of the metalworking vise. The worker threads retainer rings onto the lead screw. Then he installs the lead screw in the base. He places shuttle devices onto each end of the lead screw. He inserts spacing blocks in the channel. He moves the shuttle devices forward, using the spacing blocks as guides for the correct positioning. After removing the spacing blocks, he adjusts the retainer rings. He places steel jaws on the shuttle devices and bolts them in place. Once the thumb screw has been attached to the lead screw, the assembly is complete. Now it's over to a computerized measuring station. The controller positions the vise in the equipment, then a probe moves in. The probe compares the coordinates of the vise to a computer model and checks that it measures up to standards. Metalworking vises take 4 weeks to make and will hold up for many years. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.